Welcome back to Get in Gear Educational Standards. This is going to be lesson one, title, call it What to Teach. Now, you may remember I mentioned in the introduction, a lot of these standards, they talk about what to teach, how to evaluate that the teaching, the learning is effective, right? So we'll sort of start at the beginning, what to teach. You might kind of say the topics list in layman's terms, right? So this is just a good place to start, right? What are we going to be teaching in the first place? And as far as the topics for this video, we'll talk quickly about grade levels and bands. We'll come back to that at the end. We'll talk about the different disciplines within science. We kind of mentioned that in the intro video. And now what's going to be new here, we're going to get into a little bit more detail about these core ideas within a science discipline. So for example, in the physical sciences, what are these big four ideas relate to? How do they relate to the different grade levels? What are you supposed to know when? And then this is all kind of ultimately reflected in the standards by what you might call a performance expectation, right? So again, the what are you supposed to know? There's kind of these long cryptic codes for the performance expectations, and so I'm going to do my best to kind of decipher these for you, show you, how you could interpret the code to look something up if you have to, and then also kind of show you how these relate to the parent guides that the NGSS have published, which are, again, a little bit more in layman's terms and less technical. So let's go ahead and get started. So grade levels, as far as the next generation science standards are concerned, there's basically different, topics, expectations, what you should know for each grade level up to grade 5, right? So we see K for kindergarten, 1 for first grade, second grade, third grade, fourth grade, fifth grade. We say those are individual grade levels. And then you notice 6, 7, 8, 6 to 8, we'll call that middle school. That's a band of 3 grades, and then high school is a band of 4 grades, 9 to 12. So there's standards at all these levels, hence this document, being many hundreds of pages thick. And again, I want to do my best to kind of boil this down. Something that really makes sense to me is to kind of look at 4 bands, K to 2, 3 to 5, middle school and high school, and I'll provide a little motivation as to why I think that's a good approach and how it actually does sort of relate to the NGSS. So we'll kind of come back to that idea at the end. And this is another thing here. This isn't really so new. Also, just pointing out again, right, that these standards, they're kind of broken down by grade level. They're broken down by discipline, as you might say. And I think we saw this list in the last video. Just to refresh, there's earth and space sciences, life sciences, engineering, design, physical sciences, and modeling, right? So each of these is a different discipline, and each of these is going to have a number of core ideas associated with the performance expectations at different grade levels, right? So you can start to see how this document, how these standards, start to become quite voluminous, you might say, a rather thick document, because there's all the grade levels, all the sciences, all the core ideas under the sciences, and then that's got to sort of go together into some sort of a cohesive plan that actually sort of makes sense from the perspective of a student as they're, moving from grade K through 12. So let's break this down. The core ideas just for the physical sciences, right? Just one of the science disciplines. They're not all going to fit on one page. And it happens now. Each of the sciences is going to have an abbreviation in the standards usually. Like, for example, physical science is PS. And just to be clear here, what we're talking about with physical sciences, this is kind of ultimately the topics of chemistry and physics. Now you note that it's not broken down by class topic here. There's no mention of a class on physics, a class on chemistry. Rather, there's 4 specific topics here. There's PS1, Physical Science Core Idea 1, PS2, Physical Science Core Idea 2, 3, and 4. And now you notice PS1 is matter. That basically is like chemistry. PS2 is about how forces make objects move. This is kind of more related to physics. Kind of PS1 is sort of classic chemistry. PS2 is sort of classic physics. Now, PS3 and 4 about energy and waves, very important topic. These are a little bit maybe more kind of modern chemistry and physics, a little bit more application based. But you see that the standard doesn't just say take a chemistry course, take a physics course, right? It's kind of broken down by the topics, the core ideas that eventually would be covered in those courses. So we're going to maybe break this down further now. So we're only in physical sciences. Let's look at just physical sciences core idea number 2 related to motion and forces. And actually, I did put them all up here. Excuse me. So you see that now each of these core ideas has sub-ideas associated with it. It seems like there's kind of 3 or 4 sub-ideas for these 4 physical sciences core ideas, right? So, and again, all these correspond to all the grade levels. We'll see that in just a moment, how that breaks down, right? So again, just for the purposes of brevity, let's focus on physical sciences core idea number 2 related to physics, you might say, of how objects respond when there's forces, pushes, or pulls. And you might notice here there's PS2A, PS2B, PS2C, right? It's further broken down into those subtopics, which are about just general information about forces, how objects interact due to forces, and then kind of analyzing whether a system with forces is, quote, stable or not. And we'll look at some concrete examples because this starts to get pretty jargony pretty quick. I mean, all these words make perfect sense to me because I'm a scientist that lives and breathes these words for many decades, right? But as a non-expert, you might be starting to kind of scratch your head here a little bit. So again, we're going to kind of break down PS2. So this is, I guess, how it was done back in the day, right? The apple fell on Isaac Newton's head, and he came up with this brilliant statement that says an object at rest stays at rest. You might have heard this. An object in motion stays in motion, and then it starts to get a little complicated, a little less poetic at this point, with the same speed and in the same direction. Unless acted upon by an unbalanced force. So again, it makes perfect sense to me. I have various engineering degrees, right? And you might say in the old days, the teacher that understood what a statement like this meant told the students to memorize it, and that was somehow considered learning. And this is kind of a joke. Hopefully you realize at this point the standards are kind of moving away from, well, science is, memorizing some historical quotes, and there's even an equation, F equals ma, that goes along with this as well. So what we're talking about here now, let's get back to what the modern standards would do, like, for example, the NGSS standards for physical sciences core idea 2 related to motion and forces. Now let's look at these individual performance expectations finally. And first of all, what is the performance expectation? I kind of mentioned at the beginning of the video here that it's what to teach. And that's technically not correct. The performance expectation isn't so much from the perspective of the teacher as the learner. So this is, quote, what they should know at the end of a given year. And I put quotes on should because, of course, we don't know what's in the learner's mind. There's the whole other aspect of evaluating whether these performance expectations are actually met. And let's just say that that's another can of worms for another day. Let's just focus on the performance expectations. So the first one here related to physical sciences core idea 2 is, do you see it there? It's K-PS2-1. So now K, the first letter stands for kindergarten. This is what a learner should know about physical science core idea 2, motion and forces by the end of kindergarten. And then you see the -1, that's just a serial number. So there's KSPS2-1, -2. I forget exactly how many they are. It varies a lot by grade level. And now the way the NGSS reads here, KPS21, it's kind of like literally suggesting that the learners are playing around with balls and marbles, having them collide into each other, maybe like rolling down a ramp to get a little more speed, and just understanding this concept of pushes and pulls and interactions of objects colliding, right? So if a big marble hits a little marble faster, the little marble flies away harder. Just kind of this very basic concept of a force by kind of almost literal sandbox play, you might say. And that's the performance expectation at the end of kindergarten. And now physical sciences core idea 2 actually isn't discussed in first or second grade. It doesn't appear again until third grade, and we'll come back to this issue. It has to do with the banding, and I think it actually kind of makes sense here if you can keep a big picture perspective. So anyhow, in the third grade, this physical sciences core idea, serial number 1, is now talking not just about forces moving things, but the concept of an equal and opposite force, right? Forces can exist and an object cannot move because forces are, as we say, equal and opposite, right? So a kindergartner isn't supposed to be able to understand the concept of equal and opposite forces. By the end of third grade, they should. And if you see the diagram here, right, those balls in the middle, if you've ever played with these clacky balls, right, they transmit the forces, they don't themselves move. There's a good example of equal and opposite. I think there's a third grade PS2-3. It starts to get into forces due to magnets. Kindergartners aren't supposed to understand magnets. At third grade, it does. So they keep kind of expanding, but let's just focus on this concept of forces that aren't magnetic. Now in the fifth grade, PS5-PS2-1, the kindergarten and third grade were kind of more like horizontal forces by objects you can actually see. By the end of the fifth grade, they're supposed to understand that gravity is a similar force that's going in the up and down direction. So again, kindergarten, just that a force can move things. Third grade, equal and opposite forces. Fifth grade, oh, hey, gravity is a force too. And we're starting to introduce the concept of not just horizontal, but vertical. Now, when we get to middle school, we have middle school PS2-1. They're going to start to put a little math to it, Newton's law, and adding vectors. And then high school PS2-1, they should be able to put all this together, the real world observation, the math, maybe analyze some sort of real world system or a lab experiment. So that's just one of these, again, physical sciences core idea 2, how it sort of plays out over the years. And if you remember Newton's statement, an object at rest stays at rest, blah, 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 blah. That's what this is, kind of broken down into sort of 5 chunks of how the knowledge should grow over time. So again, it's not about memorizing, right? It's being able to apply the concept at a progressively deeper level of detail. If you took this level to college, you'd be doing something called mechanical engineering, and maybe you'd be using these ideas to analyze the forces on like a real world bridge to see if it would fall down or remain stable or not. And that kind of relates to the system stability theme that we mentioned earlier. So at any rate, it's kind of funny, right, that core idea of physical sciences too. It's if we look at it here in the second one, it's taught in grades kindergarten, and then it's skipped in grades 1 and 2. And if you notice, then we actually talk about waves in grade 1. In grade 2, we'll talk about matter. In grade 3, it's back to the motion and forces. And it seems to kind of flip-flop around a little bit, and it is a little maybe over specific in my mind, like, oh, so we teach kindergartners about forces, but first graders about waves, as if it couldn't go the other way. And I think you just have to keep in mind here that the people that were coming up with the NGSS, they wanted to actually hand teachers a plan that, kind of gave them a little bit of specific information about what to do, so that, there didn't have to be a whole nother school meeting to kind of reinterpret the standards for each school. So what I'm saying here is this actually makes a lot of sense. This is the concept of banding, right? So this is why I said if you sort of break it down, K to 2, 3 to 5, 6 to 8 middle school, 9 to 12 high school, it actually makes more sense to talk about the standards within each band. And I mentioned a few times these big codes like K-PS2-1. Those are the way it's written in the NGSS, the, multi-100-page document. Now, if you want to see the short version, a few bullet points broken down by grade band, the Next Generation Science Standards has actually already done that in sort of a plain English, really short, concise, and user-friendly parent guide, right? So I suggest if you're actually going to download documents and dig into it, start with these parent guides, right? Don't try to work through this multi-100-page document, figure out exactly what grade you're in, and take it literally. It makes a little bit more sense to interpret in these grade bands, and that's even the way that the NGSS has written it, just not in the formal technical document. So I suggest you check these out if you want to see any of their language. And that's it for lesson number 1. We're going to continue with a new topic in lesson 2. Have a great day, everybody.